Unit 1 test review. This is the video that goes with the study guide. It's a completely optional video. Please use the update feature in Schoology. Let me know if you have any questions. I'm sure there's people in your class that have the same questions that just won't speak up. We're going to be using DMS and decimal kind of interchangeably. I've shown you how to do it on the calculator. If for some reason you don't trust it, and you want to do it by hand, the instructions are right here. I'm going to do it by hand, but I am expecting you guys to know how to do this on the calculator. So when we go from DMS to decimal, you're going to divide the minutes by 60s, and you're going to divide the seconds by 3600, and then you're going to combine the degrees. You're not going to add the decimal with your whole number because it's going to throw you off if you have a negative. So I'm going to do negative 17 degrees, and then I'm going to do 36 over 60 plus 5 over 3600, and you're going to come up with 0.60138 blah blah blah. So this would be negative 17.601 degrees. Okay, you do that if it's positive or negative, but it's really important if it's negative to just combine with the degrees. To go the other way, you take and you try to get rid of your decimal. So first and foremost, if I take and have 27 degrees, okay, because that's on the left, then you have in parentheses 0.59 times 60, and that's going to give you a whole number in a second, like a whole number and a decimal number. So this is going to be 35.4. So this right now, this is your minutes. So I'm going to have 27 degrees, 35 minutes, and then take and multiply the new to decimal by 60 again, and you end up with 24 seconds. Okay. Now, if you had a decimal after that, you would use that to round your seconds, but in this case, we didn't, so we move on. You have any questions? Okay. This one, I really don't focus on too much. You know that each rotation is 360 degrees, so if I say, give me the angle measure represented by 2.5 rotations, that means that we're going to go around 2 full times and another half time. So all you do is multiply 2.5 times 360. And lo and behold, you have 900 degrees. Next card. Coterminal angles. This is the range that you're concerned about right here. As long as it's between 0 and 360, you should be good. So if I have something like 860 degrees, okay, that's not in this range. You have to add or subtract 360 until you get between 0 and 360. In this case, we need to get down to this range, so it's going to be minus 360, minus 360. And you're going to be left with 140 degrees. And 140 degrees is in between this range. If we have something like negative 832 degrees, we have to add 360. So it would be add 360 plus add 360 plus add 360. And then you're going to be within that range. I'm going to go ahead and leave that to you. Okay. But just know that it is in between that range. So that's how you find coterminal angles. Next, when you find reference angles, you got to find the coterminal angle first if it's not between 0 and 360. And then you have to use this following chart right here to tell me what your reference angle really is. So remember that this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And remember that this is 90 degrees, 180 degrees, 270 degrees. Okay. So you're trying to find the acute angle measure between your angle and the x-axis. So, for example, if I have something like, let's go with 800 again, 800 degrees, first and foremost, we need to find the coterminal angle. So it would be 800 minus 360 minus 360. So you would get 60 degrees, okay, which would be in your first quadrant. And since it's just quadrant 1, that's my reference angle. So I can go ahead and just say reference angle. If I have something like 592 degrees, okay, I still got to find the coterminal angle. So you subtract 360 degrees and you get 52. No, not 52. I hope it's not 52. No, it's 232 degrees. Okay. 232 degrees happens to be in quadrant 3 because it's after 180. So that means that we want to find this reference angle right here. So in order to do that, since we're in quadrant 3, then we have to take our coterminal angle and subtract 180. So 232 minus 180 is equal to 52 degrees. And 52 degrees is your reference angle. Questions? Okay. Finding trig ratios when you're given a right triangle. So remember, SOHCAHTOA is going to be your best friend, and c squared equals a squared plus b squared. These are your main trig ratios. And then these are going to be your reciprocal trig ratios. Let me go ahead and try to be halfway legible. So I want to find the measure, well, not the measure, but the side of angle C. Your hypotenuse will always stay the same. And you know my advice, you always should try to find the hypotenuse first, then find your opposite according to whatever angle you're using. And by process of elimination, adjacent will be the last one left. So if I want to find C, then let's have a problem actually thrown up here. So let's make this 12. And let's make this 8. First and foremost, we want to find that third side, and the hypotenuse is always C. So being that this is C, then we can go ahead and throw that in there. So let's say the hypotenuse squared. Do we know the hypotenuse? No, we don't. So we're going to have the hypotenuse squared is equal to 12 squared plus 8 squared. Okay, we don't know hypotenuse yet. So this is 144 plus 64. So hypotenuse squared is equal to 208. So the hypotenuse, when you square root both sides, is going to be the square root of 208. Okay. So sine of C is going to be the opposite over the hypotenuse. Sine is the opposite over the hypotenuse. So I'll throw this in the one time. Opposite over hypotenuse. So this is the opposite side of C over the hypotenuse. So this would be 12 over the square root of 208. The problem with this is we cannot have a square root at the bottom. So over here to the left, to the right, we're going to do 12 times the square root of 208. I want to get rid of this square root at the bottom because we cannot have radicals at the bottom. So I'm going to multiply the top and the bottom by whatever radical you have, which in this case is square root of 208. On the top, I'm not going to really do too much. And on the bottom, since we have the square root of 208 squared, those cancel out and you're just left with 208. Now I can simplify this fraction, but for right now, I'm going to just leave this here. As long as you get to this step, I'm pretty happy with that. So this is 12 times the square root of 208 over 208. Likewise, cosine is going to be the adjacent, so the side that's next to angle C, over the hypotenuse, which is the square root of 208. And if you follow that same pattern, it's going to be 8 times the square root of 208 divided by 208. Again, you can simplify this fraction, but when you get here, I'm pretty happy. And then finally, tangent is opposite over adjacent. So it's going to be 12 over 8, or it's going to be 3 over 2. These are your reciprocal trig functions, so you take these fractions, you just flip them. So it's going to be square root of 208 over 12. This one's going to be square root of 208 over 8. And this one is going to be 2 over 3. That's how you find trig ratios when you're given a right triangle. Okay. When I'm given a point, x and y, you want to find r. I always use this to remember which one is y and which one is x. Sine is y, cosine is x, tangent is the mix, so you got y over x. So if you have x and you have y, you can figure out what r is. It's still the Pythagorean theorem, except you're trying to find that radius. So it's r squared equals 5 squared plus, and then you have to put this in parentheses, negative 12 squared. So r squared is equal to 25 plus 144. Two negatives when you multiply gives you a positive. R squared is equal to 169. When you square root both sides, these cancel. And you're left with r equals 13. So you can figure these out right here. You just basically got to plug in. So y over r is going to be negative 12 over 13. X over r x over r, so it's going to be 5 over 13. And then when you mix them, it's going to be negative 12 over 5. Your reciprocal, you just flip your fractions around. So this is going to be negative 12 over 13, 13 over 5, and negative 5/12. Questions? So here's another problem where, I'm trying to fix this, hold on a second, where they give you one of the trig ratios and you need to figure out the other 5. So when we have cosine of theta equals 3 over 5 and we're in quadrant 4, first and foremost, we can just go ahead and put our fraction in now and see what 2 letters you have. Cosine of theta, if you remember your chart, is x over r. R is always positive. You should remember that from our previous lessons. So let me just go ahead and write that out. I wish I could write a little bit better on this tablet. R is always positive. Okay. So we have our y, we have our x, and we have our r. So it is going to be r squared equals x squared plus y squared. So I have 5 squared equals 3 squared plus y squared. And when you do your calculations, this would be 25, this would be 9. Y happens to be 4. Okay, so y over r is going to be 4 over 5. And remember that being that in our triangle, y is going down. So y is going to have to actually be negative. So this would be negative 4 over 5, 3 over 5. And then this one is going to be negative 4 over 3. And then over here, you just flip your fractions around. So it's going to be negative 5 over 4. This one's going to be 5 over 3. And then this one is going to be negative 3/4. If you have any questions, please let me know. We want to find the missing sides of a right triangle. So let's write this question out. Let's say if B equals 42 degrees, C is equal to 15, find B. Okay. Remember, we always need SOHCAHTOA. And let's go ahead and plug in our triangle. Let's plug in our letters. So here's A, here's B, and here's C. Here's my right angle. So this is B, this is A, this is C. I already know that C is 15. I don't know what B is, and big B is 42 degrees. So what we want to do is we want to set up our equation. We are trying to find B, and we already know the hypotenuse. Remember, I told you, always determine what your hypotenuse is first, then find your opposite. Okay. In this problem, we don't need adjacent because we're not asking what A is, and we don't know what A is. So we're going to go ahead and leave A alone. We have opposite and we have hypotenuse. So in SOHCAHTOA, since we have opposite and hypotenuse, we need to use sine. So sine of the angle 42 is equal to the opposite side, B, over C, which is 15. Algebra 1 says that we want to solve for B. So I want to multiply both sides by 15. Cross that out. And when you plug that in, you should get approximately, B should be approximately 10.03. Questions? Okay, next card. So we're trying to find the missing angle of a right triangle. So let's make this 13. Let's make this 7. We want to find capital A. So if we have the opposite and we have the hypotenuse, we have sine of A. So it would be 7 over 13, the opposite divided by your hypotenuse. We want to get rid of sine, so we would use sine inverse. And whatever we did to one side of the equation, we would do to the other. These cross out, and A is approximately or equal to sine inverse of sine inverse of 7 over 13. And that's going to be approximately 32.6 degrees. Next card. So when we solve right triangles, we need to solve everything that was not given to us. So we know 49 is going to be right here, 49 degrees. Little a, which is across from 16 and 6, A is 16. So the easiest one, if they give you two angles, the third angle is the easiest one to find. If they give you two sides, the third side is the easiest to find. In this case, we have two angles. So big A, and let's write in red. So big A is going to be 180 minus 90 minus 49. So big A is going to be 41 degrees. Okay. We can either try to find little b or little c. It doesn't really matter. Let's go ahead and say b since it's going to be the next one in order. So in order to find little b, go with the angle that you know. So let's say 49. We already know our adjacent, and how do I know? Well, this is always the hypotenuse. I keep telling you that. That's the hypotenuse. We're trying to solve for b, so this would be opposite of 49. And then 16, we already know. This is your adjacent. So to find little b, we have to use tangent because it's opposite over adjacent. So tangent of 49 would be equal to b over 16. If we multiply both sides by 16, we have 16 tangent of 49 is equal to b. So b, little b, is approximately equal to 18.42. To find little c is the same thing. Okay, let's go ahead and use the same setup that we had. We have adjacent and we have hypotenuse. So adjacent and hypotenuse, if we use that good old SOHCAHTOA. Adjacent hypotenuse is cosine. So let's say cosine. And I'm just using 49 because it's given to me. So the cosine of 49 is going to be equal to 16 over C. Algebra 1 says that we have to multiply both sides by C to get rid of that fraction. So this would be C times cosine of 49 equals 16. So C is equal to, when we divide both sides by cosine of 49, we get 16 over cosine of 49, which is approximately 24.4. Next card. If I want to solve a non-right triangle using the law of sines, then plug in your triangle. Let's go ahead and actually I'm going to use this. Okay, and let's go ahead, mark off what we know. Let's call this A, B, C. It's not a right triangle, so we have no right angle. And we know that this is 70. We know that this is 58. And we know that little a is 84. Okay, so across from the angles, this is little a, little b, and little c. So it's always easiest to find your third angle. So this is going to be for big A. Big A is 180 minus 58 minus 70. And you get 52. So big A is 52 degrees. To find little b, let's use sine of A and sine of B, since we have both the top and the bottom. So to find little b, we're going to do the sine of 52. And actually, let's go ahead and explain that. I have big A, I have little a, I have big B, but I don't have little b. So I'm going to use those two because I'm trying to find little b. So it's going to be sine of 52 over little a, which is 84, which is equal to sine of 70 over little b. When you cross multiply, it's going to be b sine of 52 is equal to 84 sine 70. So b is approximately, well, not approximately, b is equal to 84 sine 70 over sine of 52, which is approximately 100.2. To find little c, Same thing. Let's use sine of A and sine of C. So we have sine 52 over 84 is equal to the sine of 58 over little c. You cross multiply and do all that good stuff. C is going to be equal to 84 sine of 58 over the sine of 52. And you're going to get approximately 90.4. Please look at your 5.6 if you're a little confused. It goes a little bit more in depth. Next card. Finding the area of a triangle. Here are the equations or the formulas you want to use. So when we have a triangle, let's put a triangle in. Now you don't have to draw the triangle. This is for my visual people who needs to see something. Let's call this A, B, C, and we have 20. Little a is 19. Big C is 64 degrees. So when you look at your equations, there's only one that has a side that you're given, which is little a. Remember, this is little a since it's across from big A. So you're going to plug that in. K, which is your area, is equal to 1/2 a squared. So this is 19 squared. Okay. Now, we got to figure out what this is. So if I have 180 minus 64 minus 20, then we know that big B is 96 degrees. So being that we have little a, big A goes in the bottom. So it's going to be sine 64 sine 96 all over sine of 20. Plug that in your calculator. 0.5 times 19 squared times sine 64 times sine 96 divided by 20. And the area would approximately be 471.7 units. And we're finished. Any questions? Let me know.